Guys, so I'm going to illustrate what we learned today using this question. It's from 2017 paper 2. I think it's the November one. Okay, so the question says, explain with the help of equations the mechanism of the free radical substitution reaction to form that product in the presence of sunlight. So I modified the question a bit because, as you know, I never use the questions as they are, even in the test. So here, we know what we are forming. We are forming this guy over here. I didn't write the name because part of the question that I would then ask, if it was my question, would be name the product. Okay, so I didn't put the name, but I drew it. So the important thing to note here is the halogen that we're using is Br, so we must have Br2 instead of Cl2. And then the other thing that we note is that the alkane that we're going to use must be pentane because there's 5 carbons. Very quickly, let's name this. Okay, so if we number the carbons, this is 1, 2, 3, 4, and 5. It's a pent, and then the suffix is ane, and then the prefix is 3-bromo. Okay, you don't need to put space between letters when you're doing this. Okay, so now that we have that out of the way, let us now then do the mechanism. So again, when you're doing the mechanism, you have to write the title of each step. This question, as written, was a 4-point question, not 5 points. So the first step is initiation or homolytic fission. This is where we form a radical from non-radicals. And the radicals are formed using the halogen. So we have Br. Half of the bond goes to one of the Brs, and the other half goes to the other Br. Notice I'm using the head that has half. The head is half a head. Okay, we have half a head there. Okay, so this cannot happen without sunlight. So you can write sunlight here. You can write UV light, or you can write H nu or energy. Okay, in this question they've specifically told us that it is in the presence of sunlight, so you can just use that. Okay, so part of the wavelength of the radiation that comes from the sun is UV. So yeah, that's why, like I said, sunscreen, because there's UV that can start this very dangerous process. And then the second stage would be propagation. And in propagation, this is where you introduce your alkane, okay? Because in propagation, we form new radicals from existing radicals. A new radical, the existing radical, let's start with that one. We have these guys, so Br radical, this is our existing radical. And for us to form a new radical from this, we need a non-radical. And in our case, we're going to use pentane. Pentane and Br radical are going to form HBr plus pentane radical. And the unpaired electron should be in the middle. Why is it in the middle? Because our product up here is going to be connected on carbon number 3. So we have to make sure that our unpaired electron is on carbon number 3. Last step is going to be termination. Termination, we get 2 radicals to come together to form a non-radical, and we stop the process of propagation. Okay, so here, 2 radicals that should come together in order for us to form our product up here. Okay, we have a Br radical And we also have the pentane radical. So if those two come together, then we form the overall reaction without the steps in the mechanism. We have Br2 plus pentane going to HBr plus 3-bromo pentane. Et voilà!